Started.
All right. We're grateful to everyone for taking some time to join us for the webinar today. This webinar is the result of a growing partnership between GE and Dragos. Started a couple months ago as we met each other at a conference and realized that GE and Dragos are doing some complementary activities. We decided to start off trying to work out some of our joint ideas and philosophies, and now we're starting to share some equipment and some cyber intel and exploring additional partnerships. So this webinar was kind of the collection of all of this, and we decided to share it out and see what people think, see if people have additional questions and ideas that we should be working through. The webinar is scheduled for about an hour, and we'll try to reserve the last 20 or so minutes for questions. So we'll start by introducing ourselves. Reed, maybe if you could go ahead and advance the slide.
Sure.
Thanks. I'm Kenneth Crowther. I joined GE about 7 months ago. I started my career off working at Honeywell. I was a chemical engineer at a chemical plant. Went to grad school, studied quantitative risk analysis, worked as a professor for a couple of years, and then went and worked for the MITRE Corporation for the last 8 years, and came to GE a couple weeks ago. I'm a product security leader for GE Global Research and part of a product security incident response team, or a PCERT, here at GE.
And I'm Reed Whiteman. I'm a senior vulnerability analyst with Dragos. My background is working a lot as a consultant in the industrial space. I actually got started in the industrial space working for Schweitzer Engineering Labs, where I did a lot of negative testing on digital protection relays and other electric power equipment. Since then, I've been doing a lot more, well, for a few years, did a lot of globetrotting, working for both Digital Bond and IOActive, two pretty big consultancies that have presence in the industrial space. I did a lot of time, looking around at various plants, not only looking at the security of individual products, but looking a lot at network architecture issues. And at this point, I work for Dragos's intelligence group. So I'm specifically focused on looking at vulnerabilities, but I also do spend some time looking at what threat actors are doing, both malware analysis and basically their tools and techniques that they're using for spreading around people's networks.
So there are three main ideas that we want to talk about during this webinar. And each of these ideas corresponds with one of the white papers. And this has been a good back and forth between GE that designs, builds these industrial systems, and Dragos that understands in detail these the ICS systems and the adversaries and the tactics and techniques that they're using to get into ICS systems. So the first idea is that security provides the most value when it's built to support the processes. And so we'll go into this a little bit more detail, but when I first start talking to cybersecurity experts who sometimes come from the IT security world, their first kind of reaction is, if it's really important, then let's disconnect it. Let's disable remote control. Let's focus on segmentation and access restrictions. And but what we want to emphasize is that the process and the information that supports the process is what derives value. And so security needs to be built around that process. So that's kind of the first point that we're going to make. But as we are connecting things up and enabling remote control, it means that we have additional protection requirements. So, but it needs to be built around those information flows. So that's kind of the first point. The second point is that once we have identified that critical information and the connections and activities and devices that support it, then the most cost-effective way to tailor our security is by understanding the capabilities of adversaries, the processes, the techniques that they're using to exploit those systems. And now we would know where to target and what type of security measures to put in place and how to piece those security features together. And then the third point is to talk about this evolution. Sometimes the cyber community can focus on device hardening and understanding networks, but in ICS, we need to understand this in a context of the process and production systems, as well as the organization that's enabling those production systems to continue. And so we wanted to emphasize some features of this evolution as it applies to these industrial control systems. So I'll start with this first topic, and Reed, you can go ahead and go to the next slide. And I'll just start with when I first started working at it was a caprolactam plant. Basically makes toluene and ammonia byproducts to make this thing called caprolactam, which is what's used to make nylon. And one of the main processes where we put the nitrogen into the carbon ring, we had 5 parallel trains that were built at different times. So they had slightly different process architectures, different technologies. And especially some of the older lines, we were constantly dealing with irregular disruptions. And it was difficult. Sometimes it would take hours to troubleshoot what's going on, what tripped the system, where did it happen. And so one of my first jobs as a brand new chemical engineer was to understand the process well enough to document every safety interlock, every electrical, mechanical, pneumatic process that might not be on a PNID because the PNIDs weren't kept up to date. And in the end, after documenting all of these things, we cut down the troubleshooting time and the ability to respond by like 80%, saved like $1 million a year. And my next project was focused on a change in the catalyst, which resulted in looking downstream and changing the way that we connect, where we connect the process into the separations area. And again, this little change saved the company another $1 million a year in terms of energy reduction. And the point that I want to draw from this is that the more we understand about our processes, the more we understand about the information that moves and controls the process, the more we will be able to use these engineering and business requirements as a foundation for whatever it is that we're doing, whether it's doing engineering the process itself or whether it's securing the process in a way that continues to generate value for the company. And this is more especially important in industrial control systems as a foundation for security, because these control systems operate as close to 24/7, 365 as possible. And there's money that's lost every hour that these processes are down. So to illustrate how this might maybe be unexpected, we tried to pick some kind of provocative examples from some of the papers that I've seen going around GE. So the first one is in the power production process, there are a bunch of very complicated processes that happen simultaneously. So for example, if you shove more cubic feet per minute through a turbine, then you obtain more efficiency in terms of the number of electrons you get out per cubic foot of fuel. But you also wear out the turbine much faster And so you have to end up paying more for maintenance over the lifetime of the turbine. And so ideally what you would do is you would control the process where when the prices reach a certain, when the wholesale price of per kilowatt hour or per megawatt hour reaches a certain price, then you would ramp up the turbine, and when it doesn't exceed that price, then you would ramp it down, and you would do it in a way to maximize the amount of money that you're making. And just to illustrate this in the paper, we describe a process where this can potentially make the difference of $1 million a year in overall production, but it might end up requiring you to connect controllers in order to get information from outside of the enterprise. So in a second example, the one of the main losses in petrochemical companies is these unexpected shutdowns. And in order to avoid some of these unexpected shutdowns, there were some processes basically to push operational data out to a data lake. And that data lake is then analyzed by a third party, and they can predict when maintenance needs to be done, pre-stage, the equipment. And so this provisioning of third-party access provides an extra $17 million in terms of savings from what would otherwise have been lost revenue from shutdowns. And then another example is a mining company in this remote location. They're because they're so remote, when a piece of equipment breaks down, it takes sometimes weeks in order to get the part out there, and then they have to schedule very specialized skilled labor to come in, install these parts, and sometimes these outages last for 2 weeks at a time. But putting on some smart sensors and then collecting them out at a gateway and sending them allows for this predictive maintenance process to happen. And so these are just some examples that emphasize industrial control systems, sometimes the need for remote connectivity, the value that comes from remote control, the value that comes from third-party access. And we need to make sure that we're not jumping to security architectural conclusions just from not having just from what has worked in the IT security space. Instead, we need to focus on this initial first step is to understand the process itself, how those processes require information, how they move information, what information is required, what connectivity is necessary, and establish those business requirements in a clear, as a clear foundation as we start to think about cybersecurity. So one of the ways that we've thought to think through this is we've kind of abstracted this the scale of connectivity and remote control to illustrate some of these trends that we're seeing in increases in automation and machine centricity of the how the automation works, connectivity between machines, even machines that are across enterprises. We're starting to see data lakes and data availability significantly improve the value and provide roles for users who might not be the maintenance or the controls engineers on staff. And so what we wanted was a way to kind of describe how this spectrum of connectivity. And so on the left are the traditional kind of hierarchical isolated systems where a control system is within a process. That process potentially has some connectivity across the plant. There might be one or more plants on a site. That site then has a separated system. The things that we would think about when we think ISA 95 or the kind of the traditional Purdue hierarchical model. And the evolution seems to be pushing things towards the right, where we have increasing amounts of remote monitored, remote controlled, cloud-based solutions that are appropriate in different kinds of conditions where the business or the engineering, where there might be business or engineering requirements for that type of connectivity. So going to the next slide, the left-hand slide is this, what we call the Purdue model, which a lot of people on this call are probably familiar with. It still provides a good foundation for talking about different types of devices, the different operations where those devices are integrated. But for some of those systems that would be more towards the right-hand side of that continuum, it doesn't provide a good model for security architecture. That it doesn't provide a model that describes what kind of security solutions we should be integrating and how we should be segmenting our system. So on the next slide and in the white paper, we do kind of give an example of what something might look like on the right-hand side. The automation area might be collapsed and might be much flatter to allow the integrated connections between controllers and HMIs and area databases that might help to coordinate and do scheduling of operations. But in order to secure this, what we're hopefully going to start seeing is principles of zero trust networking and micro-segmentation. So the segmentation might not be level 1, level 2, level 3, but instead would be around production concept 1, production concept 2, production concept 3, so that those areas where they need to share a lot of information are then segmented from the other areas, and there's careful movement when those systems are connected. We might see, I've heard stories of engineers needing additional computational power, and so they install algorithms onto the historian, and then they have the historian, which is in the enterprise area, then send back information back to the controllers. So that would be an example of a bad security practice. If that those additional operations are needed, then that capability can be pulled onto an edge controller or something that sits inside of a more protected zone, but still allows for connectivity, but in a much more monitored and process that is more specific to controlling ports and protocols that would exist around that area. So this is kind of this first and basic concept, the idea that if we're going to do good security in an industrial control context, the first step is to understand our process, to understand the information that's required for that process to work, and to understand the connectivity requirements for that process, even if those connectivity requirements might deviate from the traditional Purdue recommendations. We need to start being able to, as engineers, communicate what those information requirements are to our OT and IT engineers so that we can start having this conversation based around what the business functions are. Reed, do you want to add anything to that as you transition to the next topic?
No, I just think, now that we've kind of looked at connectivity, it's good to keep the different levels of connectivity in mind as we talk about, threats and what bad actors are actually doing against control systems. So I guess I'll just jump in and start talking about threats. So there have been a number of attacks over the last 2 years against control systems. Some have been pretty well publicized and some haven't. The first two on this list are actually just ransomware outbreaks that happened in 2 different manufacturing facilities. They caused a lot of downtime for both of the manufacturers, which have like a real price tag associated with them. So those are, some examples of attacks on industrial systems. And then we have the bottom 2 here, the crash override and crisis attacks, are more what I would call, manual like manual threat operator people that are really trying to do something directly to the process control system. In the crash example, it might be a little bit hard to quantify a monetary loss to that. So the crash override attack was a power outage that happened in Ukraine when a transmission operator was infected. The attackers wrote some custom payloads that would actually trip circuit breakers inside of a transmission substation. But so that one, I mean, there is a slight loss of revenue there from, the transmission operator not pushing power anymore. But to me, the actual loss there is sort of a loss in confidence in the utility and in the government. And then in the case of the Saudi Arabian oil and gas company that was affected by Trisis, they had their plant tripped offline by the safety controller malfunctioning, which was actually a piece of malware loaded into the safety controller. They can actually quantify the amount of loss there, which is $9 million per day. And I think that the two events that happened at that company, knocked the plant offline for many, many days. So that money really starts to add up. And it's important when you start looking at those threats that we were just looking at, right, is to say, you're not going to patch your way out of those threats. I think it's a really common fallacy where folks say that, hey, if I just apply all the security updates to all of my industrial control systems products, I'm going to, get out of jail free. WannaCry takes advantage of, some unpatched Windows vulnerability, and these other systems or these other pieces of malware may take advantage of actual vulnerabilities in software. But, going down that kind of approach, I don't think is good. And by the way, I'm a vulnerability analyst, right? I love finding bugs and I love, making companies make patches for vulnerabilities. And even I say, like, that's not the right way to do it. 10 years ago, if you would ask me, I would have said, yes, that's great. Nowadays, not so much. But if you actually blindly apply patches, like we have in this comic, you can actually cause more problems than you solve. There were a couple of high-profile vulnerabilities that have come out through the years. One that jumps to mind right away is this Spectre and Meltdown processor bug that affected Intel. Right, so Microsoft came out with patches for Windows to help mitigate this processor bug. Well, it turns out if you install that patch, you can break a really important part of a lot of process control systems called an OPC server. That will cause your HMI systems to no longer be able to communicate to all your field devices. So if you blindly apply that patch, you're actually kind of doing the attacker's job for them, right? Because you're actually causing your own downtime and costing yourself money. You definitely need some kind of development or test environment to apply patches safely. But really, more importantly, you should look at what the bad people are doing or what these threat actors are doing before deciding what patches to apply and deciding what mitigation steps to take. So this is kind of another sliding scale here. We have a look at the various threats that affect the industrial space. These may range from script kiddies or even automated tools that take advantage of sort of weak vulnerabilities, but they're probably not going to have such a high impact on you, all the way up to these kind of national state-sponsored attacks that go after you using like new vulnerabilities or new bad pieces of software. But a lot of these do have some commonality. There's a lot of techniques that attackers use to spread around your network, no matter what level of sophistication they're at. But this scale can kind of say, well, as you progress through blocking these threats, you'll start by just taking steps to stop the lesser threats, the vandals and minor criminals. And then as you step up your game, you'll be able to stop the more sophisticated threats. So in the threat analysis world, we use this thing called the diamond model to kind of define what our threats are, right? And the diamond model is this idea that we have an adversary, and we at Dragos, we never name the adversary. Like, we don't believe in doing that kind of attribution. We think that's something that really can only be done by governments, not by private companies. But it's taking a look at what infrastructure and tools and capabilities an adversary is using, and also looking at what victims they're targeting, right? So Some examples of activity groups that we see in the industrial space. This is one that we call Electrum. These are the people that are responsible for the crash override attack, right? We know that they are targeting electric utility companies in Ukraine. We know that in the example of that specific event where they caused the Ukraine power outage, they were using a custom tool that's called crash override that manipulates an OPC server to trip circuit breakers. We also know that they were using a lot of SQL databases within the electric utility for actually spreading. They were using a feature inside of Microsoft SQL database to remotely execute commands on other database servers and pivot around the network. And we also know a bit about their infrastructure, what IP addresses they were using for command and control servers. So if you're looking at this as an engineer, you might say, well, I operate an electric utility. This is something that I'm interested in, right? Because this is an activity group that's going after electric utilities. They wrote this payload that was electric utility specific. So what on my network looks similar to what was on the Ukraine utilities network, right? Do I use a lot of these SQL databases for pushing production data out of my, energy management system or my generation DCS? Do I use the same vaguely the same tools to get data out so that my chief financial officer can see how much power we're producing or shipping? But don't focus don't focus too much on the specific tool, but focus more on the what techniques am I using that are similar to the electric utility that could be used by the attacker. So maybe you're not using SQL databases to get data in and out of your network. Maybe you're using some other historian system or something else. But that's the sort of system that you want to look at, though, is if that's how the attacker got into the network, they might use a similar technique to get into yours. So that's what you should be looking at. In the case of XENOTIME, they're another activity group that's active in this space. They are the people that are responsible for that Saudi Arabia gas plant outage. They wrote a custom payload called Trisis for infecting safety controllers. They wrote some, custom credential harvesting tools. They also used a not open source, but at least a freely available administrative tool. I believe it's called NetExec for spreading around the victim network. But this group was targeting oil and gas in the Middle East. So again, if you're an oil and gas provider, whether you're in the Middle East or elsewhere, it's still kind of an interesting group to look at. They had something really bad in mind by going after a safety control system. So even if you're not using the same kind of safety controller, that's something you might want to think about. Okay, there's an activity group targeting this sort of safety controller. We need to protect safety controllers on our network. Maybe make sure that we're keeping the key switches in the right position so that they can't be remotely programmed. Maybe even isolating them from the rest of the DCS. Those sorts of decisions go into responding to that kind of threat. Yeah, you have anything to add to that, Ken?
Yeah, so I think what's important is that the diamond model gives you a way to start to organize what threat information is relevant. So as we talked about, understanding the victimology of the adversaries, it allows us to start understanding whether or not we're exposed and going to be targeted in a similar way. And understanding those tactics, techniques, and capabilities then provides a foundation for what do we need to protect against. And it provides us a way to defend not just the networks, but defend our decisions of how we're prioritizing security across our networks to the plant manager, to put it to requirements for the vendors, to go up to the board or whoever is funding capital investment projects for a plant. So this third piece tries to tie those pieces together. And so what we've done is the reason why we had those two kind of sliding scales was so that we could then juxtapose them together and kind of give you this sense for, we're not trying to create like a maturity model. We're just trying to collect our thoughts so that we can, what we wanted to do, our primary target for this were engineers. So engineers that are designing, building, integrating processes. And we wanted them to be able to start having an intuition for some of the cybersecurity concepts so that they can start engaging in deeper, more active, more productive conversations with the OT security and IT security folks that they might need to interact with at the plant. And so this is kind of a intuition model. It's meant to kind of help tune the intuition of engineers. So the idea is that if you take your kind of level of connectivity and remote control based on the requirements for moving and connecting across your process, and if you place that on the same kind of plane against the increasing stealth organization and resources, the sophistication of adversaries, then it forms this space where you can start thinking of where are you at and where do you need to be. If you have similar industry structure organization exposures as some of the victims of these attacks that we've learned about, then like Electrum or XENOTIME, then you should have a protection that's equivalent to the more sophisticated, side of this scale. If you are a wind farm and receive a lot of value from remote control and connectivity across wind turbines, then you need to be in this upper segment of this this chart. And so what we kind of did was think through some intuition or kind of a philosophy of what this evolution might look like, starting from the bottom left, implementing basic security, moving up through, identifying your critical information and starting to have more sophisticated protection around those critical information nodes, to now integrating more of your organization so that you can manage response and awareness. And then these outer ones, now you're starting to actually generate intelligence, because now you have more visibility, understanding, and control on your own system. And you can start integrating this into your underlying business process. So just to reiterate, this isn't like a checklist or a maturity model or anything. This is just kind of a way to build intuition for how security evolves. So I'll kind of talk real quickly about the basic security. So in order to have cybersecurity, you can kind of think of this as having three things: visibility into what's going on in your process and in your control network, an understanding of what the things that you're seeing mean in the context of operations, and having control then over what systems have access to what other systems, how the information is moved, and how consistent it is with your requirements for being able to make your business work and generate value. So I was talking to a guy at the NSA, and he basically summed this all up by saying you need complete transparency of your employees, and you need to be able to start silhouetting your adversary. So this basic security means in order to have this kind of visibility, understanding, and control, you need to start by declaring clear policies of what's acceptable, what's not. You need to start creating boundaries for where the network ends, how much awareness of the process can be obtained from what part of the network. You need to start enforcing access. You need to start enforcing configuration management. You need to start controlling removable media. And this now puts you in this very basic position where you can silhouette the adversary, because you're starting to have visibility, understanding, and control of your control network. So there are some emerging capabilities. One of the first hard steps in this is that we have reconfigurable or reprogrammable devices all over. We have parts that have cyber parts inside of them, but we don't know what they are. And there are some emerging tools that work from your supply chain or your product lifecycle management system, tools to start helping you track those assets. There are companies that are starting to come up with some kind of common platform naming conventions so that they can continuously look up even these ICS devices on things like the National Vulnerability Database and vendor websites and for things like that. And they're starting to produce these reports for the IC that are tailored for various ICS environments. We're also starting to see companies have these tailored integrated baseline security stacks. And so in this case, instead of having to buy, a certificate utility and a access control utility and a log aggregator and a policy enforcement tool across your network, there's lots of vendors that are starting to come up with ways to integrate a baseline security stack that can basically be delivered and integrated directly into whatever existing combinations of assets and tools you have, so that you very quickly have visibility, understanding, and you have the setup to have control, and it gives you kind of a jump start instead of having to integrate all those things yourself. So this is the first step: is you need visibility, understanding, control, so you can silhouette the adversary. Until you've done this, you can't really do much more of anything. So this is kind of the first step, and then I'll let Reed talk about second and third phases. Reed, are you on mute?
Sorry. Yep, I am. The second step will be like looking at or identifying what your critical information is. What are the what are the data flows and assets that are on your network that you absolutely need to have available to make money. And then you'll be identifying what the normal data flows around those assets look like, and what those, basically those critical points of failure on your network are. You want to start defending those assets. You want to start categorizing, what normal looks like for them, and start coming up with disaster recovery plans, right? In case, some of those assets get knocked offline, either by like ransomware or actually a more targeted, purposeful attack. And then you'll want to be able to stage some kind of internal response, although that's probably going to be limited when you're meeting this kind of second step. You'll be doing some IR, but not a lot. Minor threats. So there are a number of tools that are coming out for this as well. I mean, we've seen there are already a lot of threat hunting network baselining tools available for the general IT world. We're seeing more of those enter the industrial space. I mean, full disclosure, Dragos is one of them. We, develop a threat hunting platform. But there are also like a lot of other neat defensive technologies that are coming online. We have everything from software-defined network switches to, more embedded device security that's been coming down the pike. For responsive awareness, I mean, once you have some of that threat hunting capability internally, and you're handling some of those like small incidents internally, this is where you're going to start thinking about, maybe using external services for, larger issues that might come up if you actually have some sort of sustained campaign that's acting against you, so that you can sort of offload some of that incident response tasking. This is where you're also going to want to start looking to pull in external threat data, right? So you might be looking to external intelligence sources to bring into your process. But this is where you're going to be getting more advanced, essentially.
And so basically, by the time you have this, responsive awareness, then this is where now you're in this condition where you have full visibility into what's going on in your process in your network. You have understanding of how those control networks work, and so when something happens, you have incident response plans. You know what to do. You have control over these processes for the purpose of doing this response. And now you're starting to make active decisions to collect information about who's coming in from outside, how they're coming in. And so you're in this position where you're starting to actually generate some intelligence, some understanding of the types of adversaries. You might even have adopted the threat diamond process. And so as we get to this, this is where we get, this is where organizations need to start integrating across their organization for more detailed cyber analytics and cyber analytic teams. This is where organizations should start taking part in industry events. I would like to say that there's some awesome, there's the perfect, ISAC already in existence. But from GE's experience, we benefit most from having, kind of multilateral relationships that we kind of cultivate internally, 2x2 or 3x3, so that we can share information. And this is this integration for organizational resilience starts to build on that internal security. So I did see that there was a question. Did we miss number 3? So we did kind of define 2 and 3 as a natural evolution from one to the other. And in the paper, there's been some additional discrimination, but we can come back to that. By the way, if this is set up to not really take verbal questions, but there is a Q&A box. If you want to type your questions in there, then we can address those questions as they come up. So this last stage, which we're calling advance your strategic coordinated agility, you can tell we kind of ran out of words for describing these evolutions. But now you're in this position where you're generating intelligence, you're benefiting from these multi-business relationships. And we have definitely seen that. I've been at several conferences, and we will be with some of our competitors. And as long as the topic stays on cybersecurity, we're best buds, we're all in agreement, we're sharing information. But as soon as it starts talking about, as soon as we start talking about features of products or next generation products, then the conversation gets really quiet. And I think this is just evidence to show that security is one of these things that we need to start working together on. So in 5, what we're the main message here is that cybersecurity eventually gets integrated into all business decisions. So we started off this by saying that information requirements should drive the desire to connect, and that connections decisions should drive how to tailor security around them. By the time you have a mature cybersecurity organization, then in some ways it kind of comes full circle. And the connectivity, the remote control requirements to make a business viable now become part of a full consideration on whether you should enter a new business venture or a new capital investment activity. This is where, instead of constantly looking at the intelligence of what's going on right now, this is where your organization will start doing scenario-based or strategic planning that looks out, trying to forecast in advance what are going to be the next tactics, given the types of controls that we enact right now. We've started to see this, and Reed and I were actually having a discussion about the counterfeit business, how the financial services sector, when they start to detect a new form of counterfeiting, then they will come up with a bunch of controls, and if the the cost of the controls is less than the cost of the fraud, then they'll actually implement those controls, which will basically push those counterfeiters to innovate something new. And so we're starting to see some experiments with how to do this internally. When I was still at MITRE, I saw an internal paper that focused on computational creativity. And what they did is they took 2,500 or so ransomware attacks, and they broke it down into the small pieces, like what's stolen, how is it reversible, what are they targeting, what was the malware, what type of weakness did it exploit, and then they had the computer generate over 8 million different next generation cyber physical combined attacks that involve ransom tactics and malware. And some of the next generation tactics didn't look anything like the current, encrypt, pay to decrypt type of ransomware attacks. They were using malware to capture physical objects and using those physical objects as ransom, or injecting, poisons and having antidotes that are available to reverse. And this type of approach to anticipating outcomes is useful when the organization is mature enough to have visibility, understanding, and control over its existing processes and how those processes work. So that's kind of this staged solution. At the end of the paper, we kind of reflect on what would have happened. There were probably we talk about 5 very ICS specific attacks. And at the end of paper 3, we kind of reflect on what would have happened if these organizations would have matured beyond the state that they existed in when they were first attacked by this. And so just some examples. Stuxnet took a long time to recognize it as a cyber incident, to then understand what needs to be done, and having visibility and awareness, having an integration between the cyber folks and the production folks, having an understanding of the types of vectors into systems, and then combining that with an incident response team would have made the reaction time much less. They would have been able to react much faster. If you think about HAVEX, and if you think about this integrated organizational resilience, where if more companies were generating intelligence and sharing it actively, this collaboration would have more rapidly noticed HAVEX as it's finding OPC capabilities across ICS spaces. If you think about Black Energy and Crash Override, if you think about their disaster recovery processes and what it took for them to go from manual back to the restoration of their initial operational processes, having joint exercises, having this kind of cross-business collaboration could have accelerated that kind of recovery. And so I don't want to spend too much time on this page with lots of text, but so you can kind of prove to yourself the value of this evolution, and we reflect on it very briefly in the paper. Reed, did you want to add anything to this, or should we?
No, I think we'll have the slides available, after the talk for folks to download, so you can look this over, or you can just grab the papers, right?
Yep.
So, to kind of summarize everything we've been talking about here today, I mean, we talked about the basics, which is kind of like first know thyself, which is not only implementing basic security, but also kind of understanding the information flows that are really important to your network, and then moved on to monitoring those critical information flows, starting to incorporate data about what threats are actually doing against the kinds of information flows that you have to have exposed for your business, and then start, hunting for those kinds of abuses. And then finally, you'll be starting to incorporate more external data, sharing that information with outside organizations, as well as taking in threat data from outside organizations and incorporating it into more of your business process. And that's kind of the big 100-foot overview summary of all the things that we've been talking about today. And I want to leave a few minutes at the end of this for any folks that have questions about our thought processes.
Yeah, and please, we would be really interested to have a discussion started across. So we gave some some ideas. We're open to you emailing either of us or both of us. We did put some forums there. There's a SANS ICS focused forum, and then there's this SCADASEC email forum, and there's a lot of back and forth about ICS. And then we have a tentative commitment from our bosses. So Rob Lee, who's the CEO of Dragos, and Nick Ritter, who's the VP of Product Security for GE, to have a follow-on webinar. So we would encourage you to ask questions to your bosses, and then have them come to that that webinar and ask our bosses those questions. And so that'll be a fun kind of thing to hear.